Section 10.2, Rational Exponents. Let's start with the following definition. Given two numbers m and n, natural numbers, remember natural numbers means positive integers. So given two positive integer numbers m and n, and suppose that little a is a real number satisfying the following. The nth root of a exists. As such, we define this thing, this is an image, it means nothing up to this point, as follows. We define it to be the nth root of a to power m, and we also define it to be the nth root of am. It looks like we're defining the same thing as two different objects, because this guy and this guy are the same. I'm defining them to be one time this and another time this one. As it happens, and we'll discuss it later, these two guys are actually the same. So we are defining this thing to be either this version of this value or this version of this common value. Because remember again, these two things are the same, and we'll discuss it at a later stage. All right, let's look at an example. Let's go to page 711. So 711, and let's do number how about number 2? Okay. The question here is, use radical notation to rewrite each expression and simplify if possible. So use radical notation to rewrite each expression. The question is, or the entity is 100 to power half. Well, clearly a is 100, the base. M is 1 and n is 2. So one more time. This guy is a. This guy 1 is actually n, and the 2 is the n. So this becomes a to power m over n. In order to write it as such, we need to make sure that the author has checked that this guy actually exists. Well, the nth root of a here in this case means the second root of 100, which means the square root of 100. Certainly it exists because a is actually non-negative. All right, so this image means either this or that, but since m is 1 in this context, these are the same, and this is nothing more than the second root of 100. But remember, we don't write 2. I mean, this guy should be written as 2, but the convention is we don't write it. So I'm gonna just erase it. Okay, and what's the square root of 100? The non-negative number, so that if you square it, you get 100. It's 10. Very good. All right, let's do another one. Let's do number 16. We have the base negative 27, and the power is 2 over 3. All right, so the base is negative 27, so this is the a, and the m is 2, the n is 3. So according to what we have in the definition, that's the same as a, or the nth root, so it's the third root of which version do we want to use? How about we use this version? Again, they are the same. Let's use this version. So the third root of -27, and the whole thing is raised to power m, and m is 2. All right, now what is that? What's the third root of -27? Well, the third root of -27, it's a number, so that if you take its third power, you should get -27. So I'm looking for a number so that if you take its third power, you should get -27. This number is -3, right? -3 times itself 3 times is -27. So this then becomes -3 squared. And -3 squared is simply 9, because it's -3 times itself. Okay. All right, let's do another problem. About number 20. We have xy to power 4/9. Well, doesn't matter which one we use, they are the same. So let's say, how about we write both of them? This is the same as the ninth root of xy to power 4. This is if you use the bottom one, because obviously a is xy and m is 4 and n is 9. So so this writing becomes this, and it has to also match this one. How about we write it too? This is the ninth root of xy, and the whole thing is raised to power 4. Okay. All right. Moving on, let's go to number 30. So number 30 here, the question is rewrite each expression with rational exponent. So they are giving us a form like this. We want to go back now. The seventh root of x to power 4. Okay, the seventh root of x to power 4. So they're giving us this writing. The base a is x, the m is 4, and the n is 7. One more time, let's label this. So they gave us the bottom one. A is x, m is 4, and n is 7. So this is the package I'm going to be using, and according to this, that's going to be a to power m over n, which means x to power 4/7. Right? Okay. How about 38? Four times x times the fifth root of y squared. Well, this guy 4 times x, as by itself, and then I'm multiplying it with the fifth root of y squared. So how about we understand what this guy is. That's the guy. I'm gonna write it with rational exponent. This guy is simply, if you take a closer look at the definition, so I'm using, according to their notation, they are writing it this way. I want to transition from this rational exponent expression to actually this writing, which uses the nth root, to the rational exponent expression. The base is y, so a is y, m is 2, and n is 5. So that's going to be y to power 2 over 5. Right? Okay. And as such, this is going to be then 4x times y to power 2 over 5. Okay. Next definition. Let m and n be also positive integers, and let's suppose that a is a real number with the property that a to power m over n is not 0. We define the following. A to power minus m over n to be 1 divided by a to power m over n. This means nothing except, once you read what's on the right, it means the reciprocal of a to power minus m over n. So this power that you see in the exponent is simply the reciprocal, right? All right. Let's take a few examples. Let's go to page 711. Go to number 40. Okay. The question here is, rewrite each expression with a positive rational exponent and simplify if possible. So we want to write it with a positive rational exponent. Here, obviously, they gave us a negative rational exponent, negative half. We want to write it with a positive rational exponent. So I'm going to appeal to what this means. This is an image that means the following. It's 1 divided by a to power m over n. So it's 1 divided by a, which is 9 here, 1 over 2. One more time. A is 9, m is 1, and n is 2. So with this dictionary, rewrite this side. 1 divided by 9 to power 1 half. All right. Now, what's 9 to power 1 half? Earlier result, it's upstairs, it's somewhere here. 9 to power 1 half, it's the second root of 9 to power 1, right? So what this means is, this is the second root of 9 to power 1, which means square root of 9. And then this is 1 over 3. Okay. Okay. Let's do another one. Let's do 46. Same question. We have 32 to power minus 4 over 5. Okay, one more time. This minus means the reciprocal, right? According to this. So who's the base a? 32. Who's the m? 4. And who's the n? 5. So that's going to be 1 divided by the a, which is 32. So 1 divided by the a, which is 32, to power m over n, so 4 over 5. All right. Now I want to simplify this if I can. So we're going to go all the way back to these guys, one or the other. So we have 32 to power 4 over 5. That's going to be the fifth root of 32 to power 4, right? That's going to be the fifth root of 32 to power 4. Let's write it. Like this. And what's the fifth root of 32? Well, this whole thing is a guy, so that if you so this guy under inside the parentheses is a number, so that once you take its fifth power, you pick up 32. What's the number so that if you raise it to power 5, you get 32? It's the 2. So that's going to be then equal to 1 divided by 2 to power 4, and 2 to power 4 is 16. So that's 1 over 16. Okay. How about 40? How about 48? So 48 is 8 divided by 125 to power negative 1 over 3. Again, minus in the exponent means the reciprocal of the a to power m over n. So that's going to be the same as 1 divided by 8 over 125 to power 1/3. Right? And let's focus just downstairs. Oops. I'll just focus on the guy downstairs. So this is 1 divided by the third root of 8 divided by 125. So what's the guy downstairs? This whole thing downstairs is a guy, so that if you take its third power, you pick up 8 over 125. So what is the number so that you cube it, or you take it to the third power, you get 8 divided by 125? Well, if you cube a 2, you get an 8. And if you cube a 5, you get a 125. So this whole thing downstairs is simply 2 divided by 5. So we get 1 divided by 2 divided by 5. You can retry it. Raise this to power 3. Take the third power of this. 2 over 5 times itself 3 times. 2 times 2 times 2 is 8. And 5 times 5 times 5 is 125. So you get this. And 1 divided by 2 over 5 is the same as 1 divided by 2 over 5, which is the same as 1 times 5 over 2. So this is simply 5 over 2 then, because 1 times anything is the thing. Okay, let's do 54. Same question for 7x z to power negative 1 over 4. What's the question again? We want to rewrite with positive rational exponents. Well, this means 7x times z to power 1 over 4, which means 1 divided by z to power 1 over 4, right? Because the minus in the exponent means reciprocal, as we discussed, as the definition says. It's right there, correct? And this minus in the exponents happens to be only for z, because I don't see parentheses for the whole thing. It's just for the z. As such, it's the reciprocal of z to power 1 over 4, this guy. All right? And z to power 1 over 4 is the fourth root of z. So we get 7x divided by the fourth root of z. Okay, the next property is the following. This is reminiscent to something you've seen before in a different course, but this is an extension of it. Let p and q be two rational numbers. Rational number means, again, it's a number that can be written as a quotient of integers. So p and q, each one of them can be written as a quotient of integers. And that a and b are real numbers for which the following algebraic expression exist. Then the following hold. So what you used to know when p and q were integers at the time is going to remain true when p and q are rational numbers. Namely the following. If you multiply two exponential expressions with the same base, you keep the base and you add the powers. If you take the quotient between two exponential expressions with the same base, you keep the base and you subtract the exponents in the following order. The exponent of the numerator, and you chip away the exponent of the denominator. And now the third property, which is taken the power of an exponential expression. You keep the base and you multiply this time the powers. And this is the fourth property, is about taking the pth power of a product. This is the same as taking the product of the pth powers of the corresponding entities. And the last one is taking the pth power of a quotient, and this is the same as the quotient of the pth powers of the corresponding entities. Okay, let's take a few examples. Let's go to page 712. And let's do number 60. Oops. So the question is, use properties of rational exponents to simplify each expression. So the properties that we just discussed above. Assume that all variables represent positive numbers. So in this context, all the variables are supposed to be positive numbers. Number 60 is x to power half times x to power 2/3. Okay. Well, this is a product between two exponential expressions having the same base. So clearly this is of this structure, the structure of this. And what do? We keep the base and we add the powers. So I'm going to keep the base, which is common x, and then I'm going to add the powers. 1/2 plus 2/3. Correct? Right? And 1/2 plus 2/3, how do we do it? We come up with the same denominator. And that common denominator in this case is 2 times 3, which is 6. Okay. I want to write half as something over 6. Well, multiplying upstairs and downstairs by 3 to come up with a 6 downstairs. So 1 times 3 is 3. 3/6 is the same as 1/2, but it's a different writing, yet equivalent, but it has that common denominator so that I can let them talk to one another here. And 2/3 can be written as, I want to write it as something over 6, so multiply by 2 upstairs and downstairs and get 4/6. So 1/2 plus 2/3 is the same as 3/6 plus 4/6. And since they have a common denominator now, I can glue them together and get 7/6. Okay. All right, let's do 64. 64 is the quotient x to power 1/4 divided by x to power 3/5. Okay. Well, this is a quotient. This is a quotient of two exponential expressions with the same base. So it's of this format. So what I'm going to do is I'm going to keep the base and I'm going to subtract the power q downstairs, which is 3/5 here, from the power upstairs, which is 1/4. So because of this property, I can write x to power 1/4 minus 3/5. Correct? And this is because of property number 2. All right. And now back to combining these two fractions. Well, the common denominator here is 20. So I get x to power something over 20 minus something over 20. All right. How did I get 20 from 4? I multiplied by 5. If you multiply here by 5, you gotta also do it upstairs, and you get 5/20 is the same as 1/4. And 3/5, if you want downstairs to be 20, which means multiply by 4, so you gotta multiply by 4 upstairs, and you get 3 times 4, which is 12. And that's the same as x to power 5 minus 12 divided by 20, which is x to power -7/20. But the question is, actually they don't say it, but how about we rewrite this that expression with positive exponent using techniques we learned before. Well, minus in the exponent means reciprocal, so that's the same as 1 divided by x to power 7/20. And I hope you understand what I'm using here. I'm technically using this property right here, this definition actually, right there, right? So I get this. Yeah, and you can leave it like that, or if you wish, you can rewrite it as 1 divided by the 20th root of x to power 7. I mean, whichever you want. And similarly here upstairs on number 60, we could have written it as the sixth root of x to power 7. Okay, same thing. Okay. Let's do 74. X to power 1/4 times y to power -2/5, and the whole thing is raised to power 1/3. Well, this is of the form, though this power, I'm taking the power of a product. This is one entity and this is another, and I have a multiplication in between. So it's the pth power of a product. So technically I'm gonna be using this guy right there with a to be x to power 1/4, b to be y to power -2/5, and p to be 1/3. And I obtain a to power p times b to power p. Right. One more time. I used this property, which is the power of a product, because the nature of this base is a product, and I have a power. So a is this guy is the b, and the p is that. So I get a to power p times b to power p. Oh, I see a mistake here. All right, let me just erase. This is a p, okay? It's the same p. There's no q here. Okay. And similarly, I don't know why I copied q. This is p. I didn't see it before. I'm sorry. Okay, let me see if there's another mistake. All right. Very good. So, all right, so you got this idea here. So the pth power of a product, that's what I applied. Okay, the next, each one of these two guys, each one of them looks like the power of an exponential expression. The power of an exponential expression. Technically, I'm referring to this property right there. It's the power of an exponential expression. What do? You keep the base and you multiply the powers. That's what I'm going to do here. So I'm going to keep each of the bases and I'm going to multiply the powers. For the first one, I get x to power 1/4 times 1/3. And for the second one, I'm going to get y to power -2/5 times 1/3. Okay. Now what do I get? I get x to power 1/12 times y to power -2/15. Correct. And this minus means the reciprocal, so we can write this as x to power 1/12 divided by y to power 2/15. Right? If you want to rewrite this guy as with the umbrellas instead, let's do it together. That's the same as the 12th root of x divided by the 15th root of y squared. Again, any of the last two expressions or quotients, any of the last two quotients is the right answer. There's no reason to prefer one in favor of the other, okay? So they just told us to simplify the expressions, to just simplify that thing. Any of the last two is a good writing for me. Okay. Let's go now to another set of problems. The question now is use rational exponents to simplify each expressions. So now we're going to go backwards. If a rational exponent appear after simplifying, write the answer in radical notation. Assume that all variables represent positive numbers. Let's do how about number 80? It's the 10th root of x squared. So all the variables are positive, so x is positive here, okay? This is the same thing as what I'm gonna use this notation right there, right? So here I have the 10th root of x squared. This is the same as x to power 2 over 10. So that's the same as x to power 2 over 10. And 2 over 10 is 1/5. So this is x to power 1/5. And then they said, if a rational exponent appear after simplifying, write the answer in radical notation. So we're gonna write using umbrellas, radical notation. This is the 5th root of x. Okay. Let's do 84. This is the 5th root now of x to power 15, y to power 20. Okay. Well, that's the same. This is what I'm going to use here. Let me highlight what I'm going to use. I'm going to use the following. The nth root of a is the same as a to power 1 over n, right? That's what I'm going to use here. So I'm going to have whatever under the umbrella is going to be the base. So in this case is all this junk, x to power 15 times y to power 20 to power 1 over n, which is 1 over 5. Okay. And now the setup is I have a power here for a product. So we're back to a problem similar to this. And which property did we use at the time? It was this one here. It's the power. It's a power of a product. So we get that this is equal to x to power 15 to power 1 over 5. So it's a to power p times b to power p. And the b is y to power 20. Okay. And lastly, here I have a power for an exponential expression. So a power for an exponential expression. We keep that base and we multiply the powers. So we're going to keep the base and multiply the powers. So I'm going to have x to power 15 times 1/5, which is 15 over 5, times y to power 20 times 1 over 5, which means y to power 20 over 5. 15 times divided by 5 is 3, and 20 divided by 5 is 4. So we get x cubed times y to power 4. This was 84. Let's do 96. Seventh root of x squared times second root of x, or square root of x. All right. Well, the first one means x to power 2 over 7. And the second one means x to power 1/2. Right? Remember, whenever the index is not written, it's supposed to be 2 here. So let me write that for you. This is a 2 here. I wrote it in yellow just to indicate we should not write it. It barely, you can barely see it anyway. All right. Okay, so at this point, I can condense the two. I have a product of two exponential expressions with the same base. I can appeal to this first property in the last list of properties we mentioned. I have, whenever you have a product of two exponential expressions having the same base, give that base and add the powers. So I'm going to just keep the base, which is x, and add the powers. So 2 over 7 plus 1 over 2. All right. I want to find a common denominator between 2 over 7 and 1 over 2. One of them is 14. So I can write this as x to power something over 14 plus something over 14. Well, to go from 7 to 14, multiply by 2. If you multiply here by 2, you gotta also multiply upstairs by 2 to preserve the value of this quotient. 2 times 2 is gonna be 4 over 14. 4 over 14 is the same as 2 over 7. You can redo it by simplifying by 2. And 1 over 2 is something over 14. To pass from 2 to 14, multiply by 7. If you multiply by 7 downstairs, you gotta also multiply by 7 upstairs. And 1 times 7 is 7. Okay, now we have a common denominator. So we have x to power 4 plus 7 over 14, which is simply x to power 11 over 14. And here the question is again the same. And I said if a rational exponent appears after simplifying, which it does appear, I mean this rational exponent, write the answer in radical notation, so they need umbrellas. Well, back to the very beginning, this one, we can rewrite this as the 14th root of x to power 11. So this product is simply this guy. Okay. Let's go to 100. I have upstairs, I have the third root of x, and downstairs I have the fourth root of x. Well, the nth root of a to power m, so a is x, m is 1, and n is 3. This is the same thing as a to power m over n. Likewise downstairs, x to power 1 over 4. So now at this point I have a quotient of two exponential expressions with the same base. I can appeal to this property right there. So take a look at it. This property here, I have this the following structure. It's a quotient between two exponential expressions having the same base. I keep the base and I take the difference between the corresponding exponents. By respecting the order, I chip away the exponent downstairs from upstairs. Okay, so I get x to power 1 over 3 minus 1 over 4. I want to find the common denominator, which is in this case 12. So I want to write each one of them as something over 12. Well, if you multiply by 4, if you multiply 3 by 4, you get 12. So I gotta also multiply upstairs by 4. 4 times 1 is 4. And to pass from 4 to 12, you multiply by 3 downstairs, and you gotta also multiply by 3 upstairs to preserve the value of the quotient. So this is gonna be 3 over 4. If you want to test it back, 4 divided by 12, simplify by 4, you get 1 over 3. And here, simplify by 3, you get 1 over 4. Okay, and this is the same as x to power 4 minus 3 divided by 12, which is x to power 1 over 12. And since the question says once you simplify, write the answer in radical notation if a rational exponent appears, well, we gotta rewrite this as the 12th root of x. Okay. Well, let's do 104. It's the 5th root of the square root of x. Well, the 5th root of a, we know that this is a to power 1 over 5, right? Think about this guy as a, and then we get that this is the a to power 1 over 5. All right, and then square root, just keep everything as is outside, and now square root of x is x to power half. It's very similar to this when you replace this index by 2. So we get that this is x to power half. And this becomes a power of an exponential expression. So again, I'm appealing to this property here. You keep the base, you multiply the powers. So I'm going to keep the base, which is x. And I'm going to multiply the powers. 1/2 times 1/5, which is 1/10. And since they want it to be written in radical notation, that's the 10th root of x. It's the 10th root of x. Okay. Let's do, so this is what? This is 104. Let's do how about 110? It's the fifth root of x to power 4, y to power 2, and the whole thing is raised to power 20. Okay. Well, let's keep the 20 outside, the power 20 outside. And we just talked about that. You see this? I'm gonna use it right there as well, with this base to be a, with this whole thing under the umbrella, the radicand, to be a. So that's gonna be then a to power 1 over 5, and a is x4 y squared times y squared, right? Okay. All right. And what's the structure here? I have something, whatever this thing is, raised to a power p and then raised to power q. So I have something, just cover that up. Just pretend that this thing is a. Okay. Let me replace it by a for you. If this is an a here, what's the answer? Oh, by the way, what's a again? It's x. Let's record this. So a is x to power 4 y2, right? So this whole thing, I'm gonna erase it and replace it by a. Okay. All right. Now the structure now becomes, it's a pth power of a, and the whole thing is raised to power q. So it's the qth power of a to power p. So we're talking about this exponent here, this property here. A to power p and the whole thing to power q is the base a to power p times q. That's what I'm going to use. So that's going to be a. Let me rewrite it in pink. A to power 1 over 5 times 20. And 1 over 5 times 20 is simply 20 over 5, which means 4. Right? 1 over 5 times 20 is, you can think about 20 as 20 over 1, right? And then how do you multiply two quotients straight across? 1 times 20 is 20. 5 times 1 is 5, which means 20 over 5, which is 4. All right, and then let's replace what a means to us. A means x4 y squared. So a means x4 y squared. And that exponent 4, I'm going to just copy it right here. Okay. And then what's the structure here? What's the language between x4 and y2? It's a multiplication. So now I have a power of a product, and power of a product, it's this property here, right there. The pth power of a product, it's the product of the corresponding pth powers. So that's going to be the fourth power of this guy, times the fourth power of this guy. Okay. And this is what? The structure of each of these factors is a power of an exponential expression, which is this, a power of an exponential expression. We keep the base and we multiply the powers. So we keep the base and we multiply the powers. Similarly for the second one, we're going to keep the base and we're going to multiply the powers. And 4 times 4 is 16, and 2 times 4 is 8. Okay. Let's do the last one, 112. This is the quotient of the fourth root of a cubed times b cubed divided by the square root or the second root of ab. Remember, when we don't have anything written as the index is supposed to be a 2. Okay. This is the same thing as the quotient of whatever the radicand upstairs is to power 1/4. Fix this. And whatever the radicand is downstairs, which is ab to power 1/2. Correct? Okay. That's the quotient of, here upstairs I have a power of a product. So a power for a product, it's this property. The pth power of a product is the product of the pth powers. So that's going to be then the pth power, which is 1/4 of a cubed times the pth power, which is again 1/4 of b cubed. And likewise downstairs, it's a to power 1/2, because again the nature of the guy downstairs is I'm raising a product to power 1/2. Raising a product to power 1/2 means it's the same thing as the product of the corresponding bases, but now to that power, individually raised to that power p. Okay, and this is the same thing as the quotient of a to power 3 to power 1/4. This is an exponential expression raised to a power. So I'm going to use this property here. A to power p to power q is the base a to power p times q as an exponent. So that's going to be then a to power 3 times 1/4 times b to power 3 times 1/4. Downstairs is a half times b 1/2. Okay, what's 3 times 1/4? 3 is the same as 3 over 1 times 1/4, straight across. 3 times 1 divided by 1 times 4. So this is the same as a to power 3 over 4 times b to power 3 over 4 and divided by a to power half times b to power half. Okay. One moment's of reflection yields that I can split the product. So I have a product upstairs, product downstairs. I can write it as the product of the following two quotients, a to power 3 over 4 divided by a to power 1 half times b to power 3 over 4 times b to power 1 half. If you don't trust me on this, go back. Multiplying two quotients amounts to taking the quotient of the product of the numerator and the product of the denominators. Okay, so we get this, and then each one of them, each one of the two quotients looks like a quotient of two exponential expressions having the same base. So for each one of them, I can employ this property right here, this one here. Again, this property is about having a quotient of two exponential expressions with the same base. You keep the base and you perform this difference. Okay. So what we get is, let me write it here below. So what we get is, oops, we get a to power 3 over 4 minus 1 half times b to power 3 over 4 minus 1 half. Correct? And now I want to subtract half from 3 over 4. I want to have a same denominator. A common denominator between 4 and 2 may be 4. So I can rewrite it as 3 over 4 minus something over 4. And I need to preserve the value to be half. Well, if you wanna pass from 2 to 4, it means you're multiplying by 2 downstairs. So do it as well upstairs. 1 times 2 is 2. Likewise here, same thing. 3 over 4 minus half can be thought of as 3 over 4 minus 2 over 4. Okay. And each one of them is going to have the power 3 minus 2, which is 1 over 4. So that's going to be a to power 1 over 4 times b to power 1 over 4. Correct? Okay. They want to write it in radical notation. Let's use one property before writing it in using radical notation. I'm going to use the last property, or the second to last property in the list of properties we mentioned. This one. I'm going to use it backwards this time. The p is 1/4. So I have a to power 1/4 and b to power 1/4. I'm going to have ab, the whole thing, to power 1/4. So I'm using it from right to left this time. Right? So I'm going to use it, as we said, from right to left. And we're going to have the 1/4 as a common umbrella for both, and then AB. Okay, using radical notation, this is the 1/4 power of something. The 1/4 power of something means the 4th root of that thing, and that thing is AB.